So how smart is AI really? I mean, are we on the verge of some kind of human-level intelligence? For years, getting a straight answer to that has felt impossible. But today, we're going to dig into this really groundbreaking new paper that gives us a concrete ruler for artificial general intelligence. We finally have a way to actually measure the minds inside the machines. But first, let's just get on the same page. What even is artificial general intelligence, or AGI? It's a term that gets thrown around constantly, but almost nobody agrees on what it means. Seriously, you could ask 10 different experts and probably get 10 completely different answers. And that's a huge problem. And that really gets to the core of it. The whole conversation is built on a moving goalpost. Think about it. First, AI masters art, and we say, okay, but can it do math? Then it gets good at math, and we say, yeah, but can it write code? We just keep shifting the definition of true intelligence. It makes it almost impossible to track any real progress or have a sensible conversation about where this is all going.
Now, this isn't just some, academic squabble. It's a major roadblock for the entire field. And that's exactly what this new research is trying to fix, to finally lock those goalposts in place once and for all. There's a quote in the paper that just nails it. It says that without a concrete definition, the gap between today's AI and human-level thinking is totally obscured. We can't see how far we've come, and more importantly, we can't see the real challenges that are still ahead of us.
So, what's the fix? Well, these researchers are proposing a stable, quantifiable framework, basically a new ruler that we can use to measure AGI consistently. No more moving goalposts, just a clear, stable metric.
And here's the definition they landed on. AGI is an AI that can match or exceed the cognitive versatility and proficiency of a well-educated adult. Now, those two words are absolutely key, versatility and proficiency. It's not enough to be a genius in one thing. AGI has to have a broad range of different skills, that's versatility, and be really good at them, that's proficiency.
Okay, so how do you measure that? Well, the researchers looked to the only example of general intelligence we've got, us. The human mind. They based their whole framework on what's called the Cattell-Horn-Carroll theory, which is pretty much the most validated model of human intelligence out there. It basically breaks our thinking down into all these different abilities, and that's why their ruler for AGI is split into these 10 core cognitive parts, stuff like general knowledge, reasoning, and a couple of different kinds of memory. The big takeaway here is that AGI isn't just one thing. It's this whole orchestra of abilities all working together.
All right, so they've built the ruler. Now it's time to actually measure something with it. The researchers took this new framework and applied it to two of the most powerful AI models we know of, GPT-4, which is out now, and the highly anticipated GPT-5. And the results? Well, they're pretty fascinating.
So check this out. According to their ruler, GPT-4 scores about 27% on the AGI scale. But the projection for GPT-5? It jumps to 57%. That's more than double. I mean, that is an incredible leap in progress. But the total score here really doesn't tell the whole story. The really interesting stuff is when you look at the breakdown. 57%. Let that sink in for a second. If this framework is right, we're already more than halfway to AGI. But getting to 100% isn't just about cranking the numbers higher. The path forward gets really complicated because of a very surprising discovery.
Yeah, the paper reveals what it calls a jagged cognitive profile for AI. What that means is that its intelligence isn't rising up like a smooth, even tide. It's developing more like a crazy stock chart with these incredible soaring peaks and some absolutely shocking lows.
And this chart right here shows you that jagged profile perfectly. Just look at GPT-5's projected scores. On things that are knowledge-based, like reading and writing, it's basically superhuman. But then, the profile starts getting jagged. Its reasoning ability, a huge part of intelligence, is way weaker. And then you hit a complete brick wall, long-term memory storage. It's not just low, it's at 0, a total flatline.
So this is the jagged truth of AI today. We're building this brilliant savant that can do these incredible things with knowledge and numbers, but at the exact same time, it's got these deep, fundamental flaws in some of the most basic cognitive machinery that we humans just completely take for granted. So let's zoom in on that most shocking deficit, right? The complete and total lack of long-term memory. What does it even mean for an AI, a system that's literally designed for learning, to have a kind of digital amnesia? 0%. This means that these models can't actually learn from their experiences over time. They can't form new, lasting memories. Every single conversation you have with one starts from a completely clean slate. This isn't just some minor bug.
It's a huge, critical piece of the cognitive engine that is just missing.
Now, you might be thinking, hang on, my chatbot remembers what I said 5 minutes ago. And you're right, it seems to. But what it's doing is actually a clever trick. The paper calls this a capability contortion. The AI doesn't have real long-term memory, so instead it fakes it. It just stuffs the entire history of your conversation into its short-term working memory, what's called the context window. It's a really impressive workaround, but it's just masking a fundamental weakness.
You know, here's a pretty good way to think about it. Relying on working memory alone is like having the superpower to read every single book in an entire library instantly. But the second you walk out the door, you forget every single word. To learn anything new, you'd have to go back and reread that entire library all over again. It's an incredible power, for sure, but it's not the same thing as true learning.
So what's the path forward then? How do we get from this jagged, amnesiac savant to something like real AGI? Well, the paper uses this one central metaphor that ties all of these ideas together perfectly, the engine analogy.
Okay, so think of an AI's overall intelligence like an engine's horsepower. That engine is built from those 10 cognitive parts we talked about. Now, some parts of the AI engine, like its knowledge and math skills, are totally state-of-the-art. We're talking Formula One level stuff. But other absolutely critical parts, like real reasoning and long-term memory, are either completely missing or just plain broken. And it doesn't matter how powerful some of the components are, because the engine's total power is always going to be limited by its weakest part. You're just not going to win a race with a broken fuel line.
And all of this leaves us with a really big provocative question at the end. AI is moving forward at an absolutely breathtaking pace, but this new ruler, this new way of looking at it, forces us to ask, if a system can't learn from its own unique experiences, if it can't form any lasting memories of its own, can it ever be truly intelligent in the way that we are? Can a machine really achieve general intelligence if it can't even remember yesterday? Answering that might just be the key to unlocking the entire future of AI.